Hi class, in this recording we're going to focus on tubular secretion, how we actively are going to put chemicals from the blood and dump it back into the filtrate within the renal tubules. Or another way, to put it more broadly, this is the way that we can actively put something into the filtrate so we urinate it out. And we have tubular secretion occurring in the proximal convoluted tubules and the nephron loop. And we use tubular secretion to help maintain acid-base balance, remove waste, and clear drugs or random contaminants. In particular, when it comes to acid-base balance, depending on our blood pH, we'll either get rid of hydrogen ions through tubular secretion or get rid of bicarbonate ions through tubular secretion. There are also various waste products that we need to just remove from the blood actively, and that includes urea, uric acid. So we have some of our ammonia or nitrogenous compounds. We have some more nitrogenous compounds over here with ammonia and creatine. We also can have bile acids as well, being actively removed via tubular secretion. And we also are going to use drugs to get, or tubularly secrete drugs, to get these drugs out of our bloodstream. Classic examples including these super common medications. We are going to need to urinate them out. And some drugs we can urinate out easier than other drugs. Some drugs have a high rate of clearance. Other drugs have a very low rate of clearance. And if the drug has a high rate of renal clearance, that means we urinate it out very quickly, which means we have to take that same drug multiple times within a day so we can maintain the desired drug concentration within our bodies. Now, within our kidney, or within our nephrons, we have the nephron loop, also known as the loop of Henle. And as we look at this nephron loop, we're primarily going to rely on salt gradients, a saline gradient in our nephron loop, so that we can collect water. This allows us to conserve water, which is a key component of making our urine. So as we look at the nephron loop, we are going to absorb lots of sodium and chloride ions within our nephron loop, and also a lot of water from the filtrate. And we use that saline gradient to maximize the rate of osmosis. As we look at the electrolytes that we absorb, it's worth emphasizing on the descending limb. The filtrate enters, and the filtrate's relatively dilute. But the saline gradient causes water to be reabsorbed into the extracellular fluid, and the filtrate becomes increasingly concentrated. And then on the ascending limb, instead of having water removed from the filtrate, instead of the filtrate becoming more concentrated, we instead remove sodium ions and chloride ions, and that causes the extracellular fluid to be more concentrated. So what we find is that the extracellular fluid near the bottom of the nephron loop has a higher sodium chloride concentration than the extracellular fluid near the top of the nephron loop. And as the filtrate ascends the nephron loop, more and more sodium ions will be reabsorbed to compensate for the water ions that were reabsorbed. We have lots of electrolyte reabsorption on the thick segment of the ascending loop. And this is done via active transport because we are moving these ions against their concentration gradients. So if we look here, we have a concentration of 500 millimolar-ish of sodium chloride within the filtrate, but within the extracellular fluid it's approximately 700 millimolars. So we're taking sodium chloride and moving it to an area of higher concentration against the gradient, which means we have to have active transport to move it there. And this active transport will keep the concentration of sodium chloride in the tissues of the medulla elevated, so that we're going to always be pulling water out of the filtrate and not letting water go back in. It's also worth emphasizing that over here, where we have the ascending limb of the nephron loop, we have thick cuboidal cells that do not allow water to pass through them. And this also helps to maintain that concentration gradient. Ultimately, what ends up happening is we have dilute filtrate enter the loop of Henle and dilute filtrate exit the loop of Henle. But in the process, we've reabsorbed a ton of water and a ton of sodium chloride. So even though the concentration hasn't changed that much, the volumes have been altered significantly. That's all we have for this recording. If you have any questions or comments, please feel free to post them on the class discussion board or to shoot me an email. And as always, happy studies.